Hello and a very warm welcome to the IAShub. Today is the 8th session of the Geography of Basic session where we shall be discussing the very basics of geography for the geography optional, right? So in the last class we were discussing about the various factors that are influencing the temperature. We have started with that topic, and in that topic we have started with the concept of wind, right? So today we will continue with the particular session where we have left behind. That is, today we'll be taking up the factors that are distributing the factors that are influencing the distribution of the ocean temperature. Now you see that, usually the ocean water temperatures are not the same across various latitudes. Why? It is primarily because of various levels of insolation which is present at different latitudes. Now insolation plays a vital role. Now coming to the next topic, it is wind. Wind also plays a role. There are factors like unequal distribution of land as well as sea as well. Then you will also find that ocean currents plays a role. Now these are considered to be the 4 major factors what influence the ocean water temperature. So today what we'll be doing is, today we'll try to discuss one factor by one factor, the role that is played and how exactly they are influencing the temperature of the ocean water, right? Now see, the temperature of the ocean water can be studied in 2 different ways. One, imagine that this is your ocean, ठीक है? ये मान के चलो ये आपका ocean है, and in this ocean you can study the temperature. One, vertical distribution of the temperature. When you go into the depth of the ocean, imagine this is 0 kilometers or 0 meters and it is at 5,000 meters depth. So at the surface the temperature of the ocean is different, and at the bottom the temperature of the ocean is different. Now entire ocean temperatures can be studied, one, horizontally. That means across the latitudes how the temperatures are varying, that is one way to study. And the other way to study is that in the depth, as you go into the interior of the ocean, how the temperatures keeps on varying, right? And what are the factors that are determining this temperature, you need to understand. So last class we have been dealing with these factors. The first factor that we discussed about the distribution of the ocean water temperature is that first one, it is your wind. Second one, it is unequal distribution of land and ocean. And the third one, it is your latitude. Okay, there's a small technical snag. Okay, third one, it is latitude. And fourth one, broadly it can be studied as the ocean currents as well. So these are the 4 different factors that influence the distribution of the ocean water temperature. Now these factors you have to study with respect to distribution of temperature horizontally and distribution of temperature vertically into the ocean, right? Yes. So last class I have asked you a question that here there's a doubt in the offline. Do you have high temperatures in the northern hemisphere or do you have high temperatures in the southern hemisphere? So NCERT has written that on an average 19 degrees Celsius is the temperature of the ocean in the northern hemisphere, and in the southern hemisphere it is 16 degrees Celsius, right? So I have told you that much of the temperature in the ocean waters are in the southern hemisphere. I'll give you the reasons why, but wait for some time, okay? Because NCERT, whatever is written in the NCERT, the language seems to be little confusing there. But when it comes to the distribution of the ocean water temperature, in the northern hemisphere, no doubt, few seas and certain areas of the ocean, the temperatures are high. But in the southern hemisphere, there are other factors that are playing. So after today's class, hopefully by the end of this class, we'll be reaching there. If not, in the next class, we'll continue with the same topic. Because you need to have an understanding about temperature, salinity of the ocean. When you study it together and then understand the concepts of thermocline, halocline and pycnocline, then you will get a complete picture of the ocean water distribution, right? Be it temperature wise, be it currents wise, be it salinity wise and density wise, right? So I'll address that point, but please be patient. Now, one by one, we'll go ahead. So today's topic is factors affecting the distribution of temperature. So in the last class, we have discussed about latitude, right? I told you, latitudinally, if you look into broadly across the globe, you will find that the temperatures are not uniform. See, you take up a particular part of the ocean and cut that into latitudes. Imagine this is your equator, this is Tropic of Cancer, and this is Arctic Circle, right? Equator, Tropic of Cancer, Arctic Circle, and Southern Hemisphere, you have Tropic of Capricorn, and then Antarctic Circle. See, much of the Southern Hemisphere, there is land absent. But broadly, in the Northern Hemisphere, except Pacific Ocean and some parts of the Atlantic Ocean, there is muchly land is dominating the part of the ocean. So, see, at the equator, if you look into, on an average, the sun rays, imagine this is your sun, and the sun rays, they are present all throughout the year, right? But while studying the climatology, we have also learned that temperatures at the equator are higher, but at the same time, because of the land absence here, there is so much of evaporation. That means here the air evaporates and there will be clouds that are formed, and it also gives you equal amount of rainfall, right? So because of that, addition of the fresh water is there here, right? There is temperature rising, and by evening there is drop in the temperature again. So collectively, if you see, it is not the equator which is having the highest temperature of the ocean water. It is the subtropical regions, which is near the subtropics. This is having, on an average temperature of the ocean is high as compared to the equator, because not much of rainfall, 3 months of summer and 3 months of winter is present in this region. But equator, 0 to 5 degrees north and south, all throughout the year, you will have hot temperatures, humid climates, every day there is rainfall, thunderstorms. So because of that, average temperature of the earth, ocean, it is higher at the Tropic of Cancer, near to the Tropic of Cancer in the Northern Hemisphere, and also in the Southern Hemisphere also, it is the same, right? Why? This is primarily because of the concept of insolation. Now, what is insolation? That is incoming solar radiation, right? And online, if you do have any doubts, please post your comments into the comment section. I'll be addressing them, right? Now come back. So latitudinal factors, if you look into, सबसे highest temperatures are present in the Tropic of Cancer or subtropical areas में, and equator will be having little less temperature as compared to tropical regions. But when you go to the polar regions, ultimately the lowest temperatures are present at the polar regions in the surface water. Clear? Now see, if you look into the temperature profile, your NCERT says that on an average at 20 degrees latitude, अगर ये मान के चलो ये आपका 20 degrees latitude है, the temperature of the ocean is also somewhere around average, it is 20 degrees Celsius, right? Now go to 40 degrees. यहाँ 40 degrees latitude पे आपका temperature हो जाएगा 14 degrees Celsius. But go to polar region, on an average, the temperature here it is 0 degrees Celsius. Look at the drastic change in the temperature. Now 20 degrees Celsius at 20 degrees latitude, this is the average temperature, and then go to 40 degrees latitude, you will find 14 degrees Celsius. Why? Insolation, right? It is seasonal insolation, and then polar region, always the temperatures are low. Now this is the influence of latitude. Latitude ka influence comes from polar region, sorry, the insolations, right? This is the first factor. Now coming to the next factor, that how exactly the temperature of the ocean is being influenced. Next is your wind. See, wind plays a very vital role into the oceans. Now, if the wind is fast, the rate of evaporation will also be fast. See here, I'm repeating, if the speed of the wind is fast, the rate of evaporation will also be fast. Now, this is little tricky to understand. Imagine that if you have, this is your ocean, and in the ocean, imagine there is rate of the sunlight will help to evaporate, right? Imagine this is evaporating. Suppose if there is no wind present, imagine that there is no wind present. So there is continuous evaporation that will take place. Clear? Now, once it evaporates, obviously the rainfall will also be in the same area. Clear? But now let's bring the factor of winds into this area. So before that, imagine this, these are the clouds that are formed if there is no presence of the wind, and the rainfall will also be in the same area. But when the role of wind comes into picture, the temperature of the ocean water slowly changes. So imagine now I've started to give the influence of winds onto this evaporation. What happens? Anything that is evaporating, don't you think that it will shift its position? The rate of evaporation of water, whichever it is there, the rate of evaporation will be more. Why? Because something which has evaporated, it will shift its position, or it moves to a different latitudes or different longitudes. That is based on the type and pattern of the wind. Right? Here clearly anything that is evaporated, now it will shift its position. Shifting of the position, it means under the influence of the wind, the same rate of evaporation, now the clouds will be moving aside. Right? Now this part of the area has another opportunity to get heated. So like that, if the wind rate is faster, slowly the rate of evaporation will also be faster. Because of that, the temperatures will also influence. Right? Now wind plays also another role in creating onshore and offshore winds. You know that in the climatology we have studied the definition of wind is movement of air from one place to another place. But why is the wind moving? Why is the wind moving? Yes, why is the wind moving? The wind moves only because there is variation of what? Variation of pressure. So wind always moves from high pressure to low pressure. Suppose, imagine that there is a landmass which is present here. Okay? Clear? So in this case, let us try to understand the case of wind. What does the temperature of the wind do? Or how does it get impacted? See, imagine this is your sun. During the daytime, the land gets heated quickly as compared to the water. Why? It is because of the concept of specific heat. Specific heat hota hi kya hai? Specific heat is nothing but you take an equal amount or equal volume of water and or equal weight of water and also the solid particles. It is the solid particles which will get heated, or else the rate of the amount of heat required to heat 1 kg of a product. In simple terms, agar layman mein bataya gaya. So why water will be having high specific heat? Because water के अंदर ना particles move हो सकता है. But लेकिन अगर मैं solid particle ले लिया, imagine this is a solid particle. If I start to give the heat, the material in this cannot move, right? But if you take a bowl of water, the material in the water can move. Because of that, heat gets distributed easily. In this, heat absorbs easily. So broadly speaking, by applying the concepts of specific heat, the land gets heated quickly and also cools quickly. Because of that, during the daytime, here the land gets heated. And once it is heated, you'll get to see there is low pressure system that will be developed and it will start to rise. Clear? When it is low pressure, the air starts to rise up and then the wind will be coming from all the directions to fill this low pressure, and water, it takes little time to heat. It gets heated only at the night time, right? And by the time the land gets cooled again. So here during the daytime, the wind will start to move towards land, right? The wind will start to move towards land and then it makes a cycle. This is how the wind starts to move. Now what is this called? Is it land breeze or sea breeze? It is sea breeze. Sea breeze. The wind that is coming from the sea is called as sea breeze, right? But during the night time, what happens? The system entirely reverses. Why it reverses? Because the land will be heated land will be heated fastly and it will also cool fastly. So night time, the land cools fastly and then the water will take some time to cool. By then already the water is having little high temperature. Because of that, it will act as a low pressure region, and then night time, if you look into the same entity, the wind will now be moving from land towards the sea, and then it makes a circulation. This is called as land breeze. See, both land breeze and sea breeze are influenced, they are also influencing the temperature of the ocean, right? Wind is playing this role. Now what else the wind plays? See, the relationship between the primary factors which influence the ocean water temperature are interlinked. Means, you see, it is wind which will help in creating ocean currents. Okay? Wind which helps in creating ocean currents. Now what are ocean currents? Ocean currents are nothing but movement of water for a longer distance into the ocean, and these currents are formed because of wind as the primary factor, right? If wind is playing a primary factor here, see, the next factor that we have to look forward is wind plus ocean currents. Wind plus ocean currents. Now how are these factors influencing the ocean water temperature? Broadly speaking, you will find that there is cold water which is present here, and compared to this water at the equator, there is warm water, right? And this warm water, always they try to maintain an equilibrium. Too much of cold water, they tend to mix with warm water, and too much of warm water, they tend to mix with cold water. So latitudinally, the temperature of the ocean is high here and it is cold here. The water generally tend to sink there, right? So look at the wind plus ocean water currents, how they are influenced. See, imagine that this is your ocean. Okay? Right? On either sides of the ocean, you have some land. Okay? This is your land, and then you also have a land, right? So let's keep this land, or let's keep this area in the wind belt. Okay? Imagine that this part of the ocean is present in the mid latitudes, or else let's consider ये आपका equator है, and this is your tropics, Tropic of Cancer, and this is your Arctic Circle, right? So look, what kind of winds do you have here? Easterlies or westerlies? What kind of winds do you have between 5 degrees north and 5 degrees south? This is your doldrum. But is it easterlies or is it westerlies in this particular region? Yes, in the climatology we have studied online. I would be expecting a reply from you. You have easterlies. Yes. Why are you hesitating to tell? It is, the winds are easterlies, right? And here you have westerlies, and here again polar easterlies, right? Now whatever is the direction of the wind, the water will also tend to move in the same direction, right? Now here you need to understand the concept of upwelling as well as downwarping. Okay? Then you will get to understand the distribution of ocean water temperature here, right? The factors of wind plus ocean currents, how are they influencing? See, now this part of the ocean is present under the influence of easterlies. So let me take you to this part of the region. Let us imagine that this is nothing but your Atlantic Ocean. ठीक है, ये मान के चलते, yeah, this is your Atlantic Ocean. So this is your equator, and these are your tropics, right? Now we'll try to understand how the ocean water circulates, or how the ocean water temperature is present in this area as well as the other side of the ocean, right? Now you take the Atlantic Ocean here. Broadly, if you look into the Atlantic Ocean, this is your Atlantic Ocean, right? Shape क्या है? एक S की तरह है. Now let's take this Atlantic Ocean and try to study. It's like this. So I've taken this Atlantic Ocean. This is the shape, right? Now here somewhere you have equator, and then you have Tropic of Cancer. In between you have the easterlies. That means this is your African region, right? And this is your South America. Do you agree? Clear? So we'll try to understand what exactly is happening here. Look, in this area, you actually have the winds are moving from easterlies, right? And this is how the direction of the winds is. What is the direction of the movement of the water in this area? They also move along with the wind. Wind plays a vital role in movement of the ocean water. Wind will act, or wind will give friction to that ocean water. Because of that friction, the water also will slowly tend to move across the ocean, right? Now, the movement of the water will be influenced by several factors that we take up in the next class. Those factors are nothing but Coriolis factor bhi hota hai. If the water is moving, Coriolis factor also. The same water will also be influenced by the shape of the continent. Suppose the color, green color, if I am using the water which is also moving in this direction, they get hit by the coastline here. Then they'll start to divert, right? So it is influenced by Coriolis force. It is also influenced by temperature, and temperature is also influenced by ocean currents. So to understand this, you need to have the concept of upwelling and downwarping, how this upwelling and downwarping takes place. See, let's try to understand. Let's go back and look into this. Imagine that this area, here you have the winds are moving in the form of easterlies, right? While they move, they also influence the ocean water which is present. In this due process, you will get to see that while the water it starts to move, it will also help the water to move. While the wind starts to move, it will also help the water to move. While this water which starts to move, it will slowly take the path, and it also moves in a similar direction of the wind. In this due process, if all the water is moving towards the other direction, other side of the wind, other side of the continent, then don't you think that there should be a shortage of water here? Of course there should be shortage of water. So here you will get to see that there is slight upwelling of the water. Why is this upwelling happening? From the depth, there is rise of water that is happening. You see, near to the surface of the ocean, you will generally have sunlight. As you have sunlight, easily the temperature of the top layer of the ocean will be little more. In the bottom, it will be little less. So when the water starts to rise up, and this water will slowly start to move under the influence of wind, right? While they start to move, they are also exposed to the sun. This water is also exposed by the sun, and they again gain the temperature. It is actually the cold water which is coming up, and this is called as upwelling, right? And upwelling pe what kind of water you will have? Cold or warm? Cold. You will have cold water, right? And then these cold waters, when they rise across this particular area, there won't be much of a rainfall. Why there is no rainfall? Because cold water, if it is present here, the air above will also turn into cold, right? Continuously, this part of the region, it will have little high pressure conditions. Now come back the same water, when it starts to travel, again it is exposed to the sun, it is traveling and they gain the temperature. By the time they reach the other side of the coastline, this water will again slowly starts to downwell. This starts to sink. And like this, it forms a cycle, right? And here it is called as down warping or downwelling. Now, is the water warm or cold here? See, यहाँ से तो पानी नीचे से ऊपर आ रहा है. It is called as upwelling. But once this water has reached the temperature on the surface of the ocean, it traveled for hundreds and thousands of kilometers and it got heated, and here the water starts to sink slowly. Why is it sinking? क्योंकि coastline पे इनको there's not much of scope that is left, and then there is a gap that was created here, and the water, while it is sinking, it will be little warm compared to this cold water, right? If the waters are warm, the air above is also warm, right? See, this part of the area, or else this part of the area will be having cold conditions. Why? Upwelling. On the other side here, warm conditions will be there, therefore there will be evaporation. Evaporation होने के कारण you will get to see that in this area there is good cloud formations, rate of evaporation is good, and this acts as a low pressure, right? And here I'm talking about the atmospheric conditions now. Now this is upwelling होने के कारण, cold conditions के कारण, you will get to know that in the cold conditions usually the air do not have much moisture holding capacity. Warm water जो है, it has more capacity to hold moisture, right? ये cold, already cold air है, or else cold air do not have high capacity to hold moisture. That is the reason why it cannot shed any of the rain, or it cannot hold any moisture. Because of this, you will be having the high pressure conditions, no rainfall, even if there is rain, very less. And like this, it is now influencing the distribution of the ocean water temperature and the climate above also. You'll get to see even the climate is getting influenced, right? So look, in the oceans there is cold water and there is warm water, and in the atmosphere also there is cold air and the warm air. Because of that, wherever you find this cold waters, wherever you find this cold water currents or cold waters, there next to that, if there is a land present in that area, you will find a desert like conditions. Okay, it is a desert like condition. Look, let's go to African Sea, right? What is this part of Africa? This is northern part of Africa. ये है desert. ठीक है? Why is this a desert? Because here you will find the water to be upwelling and cold conditions, and this area is mostly dry desert, right? क्यों? क्योंकि यहाँ पे upwelling हो रहा है. Now the same water, while it traveled all the way, it attained temperature. When it attains temperature, you'll get to know that the evaporation, there will be cloud formation, again you'll have good rainfall, right? So this is how the distribution of temperature is influenced by the winds and the currents. Now these currents, we'll learn in the next class how the currents move, what are the factors that influence the movement of the currents, and Coriolis force का क्या role है, upwelling, downwarping, in little more detail. Today you got to learn that temperature plays a vital role of the ocean water temperature, and in that particularly it is influenced by winds, it is also influenced by latitude, it is also influenced by ocean currents, and the other last factor is unequal distribution of land and ocean. So in the last class we have clearly discussed this unequal distribution of land and ocean. That is the reason why you will find enclosed seas agar hai, they will be having little high temperature because land gets heated quickly and the temperature can be distributed to the ocean as well, right? So broadly speaking, there are 4 different factors which has influenced the ocean water temperature, right? Let's quickly look and revise land breeze, sea breeze के बारे में भी पढ़ा. Why is it formed? It is formed because of wind. Come back. We have studied about wind, latitude, ocean currents, and unequal distribution of the temperature. Now, what we will do is we will try to cover up the temperature of the ocean across its depth. ठीक है? Vertical profile of the ocean. Vertical profile of the ocean means, imagine that this is the ocean, right? In the ocean, let's study this temperature, how and what kind of temperatures you will find into the oceans when you go in the depth, right? Firstly, broadly speaking, imagine that you have a sunlight, right? ये है आपका 0 meters at the ocean and this is near about 5000 meters मान लो, right? Depth of the ocean. Now there is sunlight. To what depth the sunlight can penetrate into the oceans? Maximum of 200-300 meters. उससे ज़्यादा तो sunlight penetrate नहीं कर सकता. So wherever there is sunlight present, the temperature of the ocean water is also influenced by sunlight. Number 1. Secondly, we have studied the temperature of the ocean water is also influenced by wind. If there is wind moving in this direction, imagine that there is wind moving in this direction. ठीक है? So there is also upwelling here and there is downwarping here. So that is also how your ocean water also distributes, right? Now this is horizontal motions we have learned, but now we'll look into the vertical component. Come back here. The entire vertical profile of the ocean can be broadly divided into 3 different layers. Right? 3 different layers ko you can divide. Now that first layer, if you look into, it is called as top layer, and in the top layer, the maximum depth you will find is up to 500 meters tak. ठीक है? 500 meters tak, this is called as the top layer. In the top layer of the ocean, you will find insolation receiving. On an average, the surface sea temperature, if you look into, it is near about 27 degrees Celsius होता है in most of the seas, and average अगर देखा गया, northern hemisphere is 19 degrees Celsius. I'm talking about average surface ocean water temperature only. ठीक है? Look, you need to be very clear when a question is asked, is it surface water temperature or is it ocean water complete temperature? Surface water matlab only they are talking about 0 to 500 meters temperature. ठीक है? Bottom water means they are talking about the water present in this layer, right? ये मान के चलो, अगर आपका जो टेम्परेचर है यहां पे 27 डिग्री सेल्सियस मान के, let's assume, right? Imagine, let me also put the profile of temperature here. So imagine on this scale, if this is 27, 25, 24, 20, 15, 10, 5 degrees Celsius. So imagine this is your ocean. At the surface, you will have 27 degrees Celsius, but go little down in this area, you will get to see there is a drop in temperature like this, right? क्यों? क्योंकि sunlight, it can only penetrate into the top layers, and slowly as you go little deep, the temperature drops, right? यहाँ इस height पे आपका 27-25 degrees देखने के लिए मिला, but you go down, you will get to see little less temperature. Until 500 meters, there is a drop in the temperature, but at the 500 meters, you will get to see a drastic drop in the temperature like this. Why? Why did you see? And this is called as the second, or else this is called as the second layer. And you got to see a drastic drop in the temperature of the ocean water. But why did you get to see this drastic change in the temperature of the ocean water? It is because this drastic change is because in this area you will not find the sunlight. Sunlight na hone ke karan, temperature of the ocean water has drastically dropped, and this layer is also called as, anyone? It is thermocline. It is called as thermocline. Thermocline is a region where you will get to see the temperature changes very rapidly. Now this is present between 500 to 1000 meters ki beach mein you will get to see. Right? You will get to see this temperature up to 1000 to 500 to 1000 meters. Decrease in temperature with increase in the depth. This is what you will get to see. Decrease in temperature with increase in the depth. Now come to the third layer. In the third layer, you will broadly see that the temperature of the ocean is nearly same. ऐसा क्या होगा यहाँ पे 4 डिग्री सेल्सियस, 5 डिग्री सेल्सियस, 4 डिग्री, 3 डिग्री सेल्सियस you will get to see. Now this is called as the bottom layer or the third layer, and broadly 90% of the water, where exactly it is present? It is present from the second and third layer. 90% of the water is present here by volume, and only 10% of the total water is present here. Only 10% is present in the top layer. Rest 90% of the total volume of the water is present here. Now whatever the water circulations that you got to see in the form of currents, they are also defined as surface water currents and deep ocean currents, and deep ocean currents are also called as thermohaline circulations. ठीक है? Deep ocean के अंदर also, here also you'll get to see the currents moving, but the rate of movement of these currents, it takes thousands of years to move from one position and to come back to the same position. Now whatever you are seeing, the surface ocean water currents, the movement is here itself. It is, imagine here you have easterlies, and then you will also get to see the movement of ocean water in the same way. It is, you'll get to see there is upwelling here, they'll travel all throughout, and then they sink and they take a circulation. It is not like that the entire water sinks to the bottom of the ocean. No, not every water can sink to the bottom of the ocean. Most of the circulations, it is this because of a factor called Ekman effect. ये Ekman effect क्या है? We'll try to study tomorrow in the next class. Ekman effect कुछ ऐसी प्रिंसिपल है, अगर आप डेप्थ में जाते हो, the water will slowly drift its direction, and this is called as Ekman effect. This we are going to study in the next class in the ocean water currents, and today we'll restrict ourselves to this particular topic. So this is called as the particular temperatures across the depth of the ocean profile. Now this is called as vertical distribution of the temperature. So अगर ये मान के चलो सबसे ज्यादा टेम्परेचर कहां पर होगा across the earth? Ocean water, subtropical regions, right? Subtropical regions में 27 degrees Celsius है, right? But when you go to the polar regions, what will be the temperature there? Zero. मतलब on an average यहाँ पे polar regions में temperature zero है. So it is nearly you will get to see some same temperatures in the polar regions. ज़्यादा कुछ variation नहीं देखने के लिए मिलेगा. You will get to see hardly, the variation is not much in the polar regions, but you go to the subtropical, so you go to the mid latitudes region जहाँ पे 35-40 degrees latitude पे जाओ, वहाँ पर भी temperature is not much, 15-16 degrees Celsius होगा, and then it drops very drastically, and then it maintains a near uniform temperature at the bottom of the ocean. राइट बट लेकिन अगर आप टॉप लेयर देखते हो, ये मान के चलो दिस इज योर टॉप लेयर, राइट? दिस टॉप लेयर is very predominantly present in the subtropics and seasonally present in the mid latitudes. This top layer is present all throughout the year in the subtropics, but it is sometimes absent in the mid latitudes. Matlab around 35 degree latitude per it is absent, right? So vertical distribution of the temperature and horizontal distribution of temperature, these are two different things. Right. Now coming to the horizontal distribution of temperature, that means how the temperature is being distributed on the oceans. Here, this is under the influence of one, wind, second one, latitude, third one, ocean water currents, and fourth one, unequal distribution of land and sea. Okay. So this is nothing but the distribution of ocean water temperatures in the ocean, both horizontally and vertically. Once let me show you a map which will tell you how exactly is the distribution of temperature being present across the globe. Now देखो ये जो map है ना, I've already directly taken it from the NCERT. Look, spatial pattern of the surface temperature of the ocean. The temperature of the ocean which NCERT discusses, that annual average temperature of the northern hemisphere is more. It is only confined to the surface water, but they do not take into account the bottom water. ठीक है? अगर collectively bottom water भी ले लो और surface water temperatures also you calculate, and there are seasons also, multiple factors are involved in this, then you will understand that actually the ocean water temperature across the globe, if you calculate comparative to northern hemisphere and the southern hemisphere, now some research says that it is the southern hemisphere on an average is maintaining little warm temperature. Holistically, depth profile and horizontal profile, this is the recent research that came up. So that's the reason why I asked you, do you have high temperatures in the northern hemisphere or southern hemisphere all throughout the year? Right? That is some news article. Now come back, on an average agar dekha gaya, surface water temperature only if you take into account 16 degrees Celsius is the southern hemisphere and 19 degrees Celsius is the northern hemisphere. That is given in your NCERTs also. Now come back, on an average, you see, it is the Arabian Sea, sorry, Bay of Bengal and Arabian Sea. Why do you have the difference in temperature in these two seas? What is the major reason? दोनों same latitude पर है, but लेकिन the Bay of Bengal is having 28 degrees Celsius of the surface ocean water temperature, but 25 degrees Celsius of the Arabian Sea. Why? क्या reason हो सकता है? Yes. What could be the major reason? I'll be waiting for 10 to 15 seconds for your answer. Online students, you can also mention your answers into the comment section. Why do you think is the major reason? Dekho, here comes into the picture various factors. For example, let's try to understand this. Imagine I have two bowls. And I have, this is salty water and this is fresh water. Which one will get heated fast? I give same amount of temperature to both the bowls. Which one do you think will get heated fast? Fresh water. Okay. So here comes into the picture the concept of salinity. Salinity will also influence the ocean water temperature, right? So you broadly look into the Arabian Sea and Bay of Bengal, you will understand that. देखो, Bay of Bengal में यहाँ से you have Brahmaputra, Ganga, Brahmani, Baitarni, Mahanadi, Godavari, Krishna, Kaveri, and multiple rivers. Plus you will also have Iravadi. इतने बड़े बड़े rivers, they are draining into the Bay of Bengal. So The depth, more or less, they are same. The depth here is on an average 3000 to 4000 meters ki depth hai. So imagine this as a bowl of water. Now in this, there is addition of fresh water is there. Because of the fresh water, the salinity is comparatively little less. Now you look into this bowl. यहाँ पे रिवर्स अगर देखा गया, एक ही रिवर, बड़ा रिवर जो है इंडस, रेस्ट आर वेरी स्मॉल रिवर्स, they do not add much volume of water to the ocean. And also you look into this area, most of the area, this is your desert area, right? And these desert areas will be having some desiccating effect. Desiccating effect kya hai? Desiccating effect means, suppose there is air which is cold in nature, or even if there is warm air, it is not having the potential to rain. It will create dust storms if there is no moisture present. Because of the local conditions and the monsoonal winds conditions, और यहाँ पे easterlies भी होने के कारण यहाँ पे ज़्यादा बारिश नहीं होता है. And this is little salty. So इसीलिए on an average the temperature of the Bay of Bengal is 28 degrees Celsius. This is 25 degrees Celsius. And this is also the same reason. If you look into the cyclones, tropical cyclones, I think we have discussed. Did we discuss tropical cyclone topic? No, we haven't. Okay, in the further classes we'll discuss what is a tropical cyclone, how the cyclones are formed. Cyclone formation के लिए the major requirement is that on an average the ocean water temperature should be 27 degrees Celsius. And these conditions can be easily attained into the Bay of Bengal than the Arabian Sea. ये इनका मतलब ये नहीं है अरेबियन सी में साइक्लोन्स नहीं होता है, साइक्लोन्स होता है, बट लेकिन these cyclones will not come and hit India. They go and hit either Iran, they go to Pakistan, they go to the Middle East area and they hit there. Why? Again, Coriolis force we'll learn in the further classes. Come back. So any cyclone which is formed here, it goes and hits India, right? So latitudinally अगर देखा गया, these two seas are lying in the same latitude, but they are having different temperatures, right? Difference in salinity. So salinity and temperature are also interlinked. It doesn't mean that if a particular area is having high temperature, it will have high salinity. It's not like that. There are many major factors that influence the factors of salinity, right? So salinity also influences the temperature of the ocean. Temperature will also influence the salinity of the ocean, right? Now let us try to understand the concept of or the linkage between salinity and temperature. Suppose यहाँ तक clear है? Any doubts? Are you clear with this? So let's go further. Now we'll try to understand the concept of salinity and temperature. ठीक है? Firstly, you need to know the concept of salinity and how is it measured. So salinity is measured in parts per thousand. ठीक है? This is written like this, parts per thousand. Now what do you mean by parts per thousand? You take 1000 grams of water. Imagine this is a bowl, and in this bowl you have 1000 grams of water, and this 1000 grams of water is nothing but 1 kg of water you take. And in this 1 kg of water, how much amount or how many parts is this salt present? ठीक है? In this 1000 grams or 1000 parts, if you have 30% of water is salty, that is called as the ocean water. The ocean salinity is 30 parts per 1000, right? So to divide or to calculate the ocean salinity is always measured in parts per 1000, and in this parts per 1000 the calculation is based on 1000 grams of water is taken, and in this 1000 grams of water, how many parts of water is having salt, right? So this is called salinity. Now see, the relationship between temperature and salinity is like this. Imagine this is a bowl of water, right? Again, you have a different bowl of water. right? Now in this, the salinity of the water is 25 parts per thousand मान के चलो, and here also you have 25 parts per thousand, right? Now what I'll do is I'll start to give temperature which is higher. Look, temperature, imagine I'm giving a temperature of X temperature, or maybe 80 degrees Celsius, or let's not exaggerate, let's call it as 40 degrees Celsius of temperature is having to this particular bowl. And this bowl only has 15 degrees Celsius. ठीक है, टेम्परेचर किसमें ज्यादा है? इस बाउल में, इसमें भी 25 पार्ट्स पर थाउजेंड है, इसमें भी 25 पार्ट्स पर थाउजेंड है. तो ये मान के चलो 40 डिग्री सेल्सियस पे एवोपरेशन ज्यादा होगा या 15 डिग्री सेल्सियस पे एवोपरेशन? 40 पे ज्यादा होगा. तो इमेजिन देयर इज वाटर एवोपरेटिंग. Now you should understand that anything that evaporates, it is always fresh. ठीक है, evaporation happens by the fresh water, right? Impurities थोड़ा late evaporate होता है. So here also you got to see evaporation. Now this is 1 liter and this is also 1 liter. Now imagine in this 200 ml got evaporated. Here only 100 ml got evaporated, right? तो यहां पे कितने बचा अभी? 1 लीटर में से 200 ml, यहां पे आपके पास 800 ml बचा है पानी. ठीक है, that means this is 800 ml is left. Now here 100 ml, that means how much water is present? 900 ml is present. अर्लियर कितना पानी था? 1 लीटर. तो अर्लियर सैलिनिटी कितना था दोनों का? 25. बट लेकिन नाउ सी द सेम 25 पार्ट्स पर थाउजेंड इज नाउ प्रेजेंट इन 800 ml. ठीक है, हियर 900 ml में 25 पार्ट्स पर थाउजेंड इज प्रेजेंट. सो इफ यू increase the temperature of the ocean, the rate of evaporation will be more, and ये जो है ना salinity भी बढ़ता है. It is the same amount of salinity is now present in less amount of water, right? So because of that, temperature अगर कहीं जगह ज़्यादा है ocean के अंदर, the rate of evaporation will also be more. And then if there are no winds present, see, imagine if there are no winds present here, winds नहीं है, that evaporated water will again fall in the form of rainfall. But ideally there are no such seas, there are winds are absent. Oh sorry, there are no such seas, there is wind, absence of wind. Always every sea has wind. So because of that, this evaporated content will now reach to a different place. And evaporation ज़्यादा होने के कारण salinity of the ocean will also increase, right? If the temperature of the ocean water is more, the salinity of the ocean water will also be little high. Got it? But listen, you need to understand, it is not only the temperature which influences the salinity of the ocean. Salinity of the ocean can also be influenced by other factors. Temperature एक ऐसी फैक्टर है, ठीक है? हम टेम्परेचर को लेकर ये डिसाइड नहीं कर सकते इस जगह पे सैलिनिटी कम है तो टेम्परेचर की कारण ही है, ऐसा नहीं. टेम्परेचर एक फैक्टर है, इनमें से टेम्परेचर इज वन ऑफ दोस फैक्टर्स. नाउ कम बैक, बाय यूजिंग दिस लॉजिक, इफ आई आस्क यू दैट दिस इज योर अर्थ, सबसे ज्यादा एवोपरेशन कहां पर होता है? इक्वेटर पे ज्यादा एवोपरेशन है. हैव यू हर्ड ऑफ डोलड्रम्स? हैव यू हर्ड द कॉन्सेप्ट ऑफ डोलड्रम्स? डोलड्रम क्या होता है याद है? 0 to 5 डिग्रीज की लैटिट्यूड्स की बीच में मैंने ये कहा था विंड्स आर एब्सेंट देयर, राइट? सो देखो सबसे ज्यादा एवोपरेशन ना, इट इज एक्चुअली प्रेजेंट इन द ट्रॉपिकल रीजन्स, सॉरी इक्वेटोरियल रीजन्स इटसेल्फ. बट लेकिन यहाँ एब्सेंस ऑफ विंड के कारण देयर इज एवोपरेशन हैपनिंग एंड द क्लाउड्स आर देयर, बाय इवनिंग देयर इज रेनफॉल. सो इसीलिए the role of winds also plays the kind of salinity it has. So see, there is rise of temperature, again water got evaporated, sham ko you'll get to see rainfall, right? Addition of salt, the salt is present, and then water is evaporating, by evening the same water is getting precipitated. So इसलिए इस जगह पे salinity का इतना ज़्यादा variations नहीं मिलता है, right? But come to the tropics. Tropical area में wind is also present, very nicely present. Rate of evaporation is also high again. Why? Temperatures are present. So because of that, in this particular area, you will also see salinity plus temperature दोनों ज़्यादा है, right? Salinity and temperature ज़्यादा है. लेकिन यहां पर जाओ, पोल्स, टेम्परेचर क्या है? 0 डिग्री सेल्सियस, राइट? अगर 0 डिग्री सेल्सियस है तो सैलिनिटी क्या होना चाहिए? काफी कम होना चाहिए. इनफैक्ट रियलिटी में ऐसा है. लेट मी शो यू बिफोर यू कम टू ए कंक्लूजन. See, your own NCERT says that the salinity patterns, if you look, it's not like that. देखो, ये ocean surface salinity है. Salinity देखो in the tropical regions, Tropic of Cancer है ना? I hope this is visible to the online students as well. So Chinar says that in 800 ml of water the salinity will get increased. Good Chinar, very good. Now come back. See, यहाँ पे कौन सा salinity है? 37. This is Tropic of Cancer, right? ये है Tropic of Cancer. But लेकिन ऊपर जाओ, 33, 35, 35. Look here, 34, 36. अलग अलग वेरिएशन है. देखो, अगर आप टेम्परेचर के हिसाब से देखा गया, यहां पे तो सबसे कम सैलिनिटी होना चाहिए, लेकिन है नहीं, क्योंकि यहां पे मल्टीपल फैक्टर्स कम्स इनटू पिक्चर. वी हैव स्टडीड only one concept of temperature, the salinity today. Salinity is influenced by addition of fresh water, rise in the temperature. अगर ये मान के चलो, if a particular area is getting converted into sea is getting converted into ice, will the salinity increase or will the salinity decrease in the sea? Suppose, let us consider that you have a particular area, यहां पर sea है, ठीक है? Just a minute. So let's try to understand the same thing. Imagine this is a bowl of water, this is also a bowl of water. Here, some part of the ocean has converted into ice. ये पूरा ice बन गया. तो यहाँ इस पानी में salinity बढ़ेगा कि कम होगा? सेम लाइक नहीं, ऐसे नहीं. देखो, यहां पे क्या है ना, आइस हमेशा फ्रेश वाटर से बनता है. ओनली वेरी लिटिल आइस इज फॉर्म्ड बाय द सॉल्ट वाटर. आइस नीड टू बी फॉर्म्ड फ्रॉम फ्रेश वाटर. सो 1 लीटर की पानी, ये मान के चलो पहले इसके अंदर 200 ml का वाटर इज नाउ कन्वर्टेड इनटू आइस, राइट? अगेन 800 ml ऑफ वाटर इज लेफ्ट, राइट? सो सैलिनिटी बढ़ेगा इसमें. वाटर, डिड नॉट गेट इट, वंस रिपीट द क्वेश्चन. यस, विपुल का क्वेश्चन ये है, सर ऊपर का लेयर तो आइस बन चुका है, अभी एवापोरेशन तो नहीं हो सकता, राइट? देयर इज नो एवापोरेशन, बट स्टिल you have to understand the concept that even if the ice formation is active in that particular area, the salinity of the water will be high. Why? You understand this concept. Imagine that you have two bowls of water. ये भी 1 liter है, and this is also 1 liter. ठीक है? 1 liter, 1 liter. Now in this, see, इनमें से fresh water is also present. Some parts of the water is fresh, some parts of the water is salty. ठीक है? So let's imagine 30 parts per 1000 of salt is there in this, 30 parts of salt is present in this. Now in this 200 ml of the water, which is fresh comparatively, it is turned into ice. So let me convert this part of the ocean into, यहां पे पानी कितना बचा, 800 ml बचा गया। इस 800 ml के इस 800 ml की पानी का सैलिनिटी क्या होगा? Obviously, that means you got to understand, even if thawing or freezing, this is called freezing. If the same freezing water melts, it is called thawing. So both thawing and freezing will also influence the temperature. But लेकिन इस एरिया में evaporation इतना ज्यादा नहीं होता. First factor, what did we understood? We understood that if there is rate of evaporation high, the salinity will also be high. Why? क्योंकि fresh water is getting evaporated and the salts are left behind. In the second case, if there is ice formation also, then also you will have high salinity. So this type of formation is called as ocean exclusion. ठीक है? Ocean exclusion कहा जाता है इसको? We'll learn this in very detail in the further classes, but today I am running little fast so that you are already comfortable with 5 to 6 classes of content where you can easily understand. Right? The same concept, you should not always take up एक particular factor को लेकर कभी decision पे नहीं आना चाहिए. अगर आप salinity decide कर रहे हो, if you are deciding a particular area salinity here, right, you have to take multiple factors into account. Right? For example, you imagine किसी ने आपसे पूछा, अरे यार यहाँ पे salinity क्या होगा? यहाँ पे तो temperature कम है, but लेकिन salinity भी तो कम होना चाहिए. It's not like that, because you cannot decide salinity on the basis of one single factor. When it comes to polar region, the dominating factor is freezing and thawing. When it comes to equatorial and subtropical region, it is evaporation. Right? Temperature और salinity का absolute relationship नहीं है. It is a relative relationship which is there, but multiple factors are also taking into an account. Right? So अगर किसी ने blindly पूछ लिया temperature और salinity का relation क्या है, direct relationship is not there, indirect relationship होता है. ठीक है? क्योंकि यहाँ पे freezing in thawing में भी salinity is high, temperature is less, but लेकिन यहाँ पे देखो temperature तो ज़्यादा है, evaporation भी ज़्यादा है, इसलिए salinity ज़्यादा है. Right? So in the next class, what we will do is we'll take the factors that are influencing the salinity and also how the salinity will decide the movement of the ocean water in currents. So as you go into the depth layers, you will identify that a particular layer which will be formed like thermocline, that is called as halocline. HALOCLINE. Halocline के बारे में पढ़ेंगे. अगर salinity of the water is high, the density of the material will also be high. The density of the water will be high. Right? So when you have the weight of the water more, always the heavy water will try to sink in. So all these relations will try to understand, and usually students get confused in this particular topic itself. So salinity पढ़ने का तरीका अलग है. You go and read the NCERT for the basic readings. Chapter number, I'll tell you which chapter to be read. It is chapter 13. Chapter number 13 of 11th class NCERT. This is what you have to read. And if you do have any doubts, अगर आपको कोई doubts है, you can directly message me here regarding the topics that we have discussed. Right? And geography optional batch is soon going to start. This is my contact number. Now, this is a humble attempt where we wanted to give you a basic clarity about the geography basics, because many of the students, they do not understand a particular optional and they directly jump in. So this is a very good attempt which we are trying to give you that basics, ताकि आप एक informed decision ले ले. या is this the right optional for you? Is this the good optional for you? Because there are many misconceptions about the optional that study take after 6 months, they decide that this is not my optional. So if you do have any doubts regarding the optional, you can give me a message. If it is urgent, then only calls, right? And our optional batches are going to start by 25th of this month. Before 25th of this month, you can get enrolled. The contact numbers are given below. Thank you and see you. We'll be seeing you in the next class.